All right, guys, so for today, we are still solving, but we are looking at what happens when you have more than just fraction equals fraction. You're going to have some extra stuff going on, okay? So note that you're on a different column of that flow chart that I gave you. Your red paper, we're now on the next column that says more than two fractions. Okay? So there's the problem. What's step one say? All right, so now how important is it that you read this red paper? Because yesterday, did it ever tell me to factor? Never told me to factor yesterday. Yeah, it didn't. Because yesterday you just wanted to cross multiply first, and then the fractions went away. Right? When we're solving, I don't want to deal with those fractions. So our goal is to get rid of them entirely. Yes. Yes. All right, so step one said what? Factor denominators? Okay, do either of these factor? Do I have, how many denominators do I actually have? Good. I do have 3. So if you have something that's not a fraction, please put it over 1 so you don't forget that there is a denominator there. Okay, what does step 2 say? Least common denominator, your LCD. So again, guys, when we talked about your LCD, we did this when we were adding and subtracting. You want every part and piece accounted for, and you're going to really see today why every part and piece has to be accounted for. So what parts and pieces do we have? Do I need the 1? You know what? For today, just for this problem so you can see it, I'm going to write it down. Because I want every part and piece. Now we know multiply by 1 doesn't change anything, but I want you to see it. Okay? So what's your next step say? Okay. Now at this point, with adding and subtracting, you only multiplied by the missing piece. Here does not say missing piece. This one says multiply by the entire LCD. And let me show you why. And now, those of you who like to be lazy, I totally get it. You know that's me. I'm not lazy here. Okay? So the one time I'm not lazy. I know it's the one time. You can give me one time, right? One time not to be lazy. Because sometimes the LCD is long and people get tired of writing it. So you're multiplying every single part, right? I got to be fair, by the entire LCD. So 1 and then x minus 2. 1 and x minus 2. 1 and x minus 2. Now it says in that step you are multiplying by the LCD to cancel the denominators. Now notice it did not say smoosh. I'm actually multiplying, and my goal at this step is to cancel all my denominators. Okay, we clear on what the goals are. So when I look at this, I want to cancel my denominators. So I can cancel this x minus 2 with this one. So I'm looking at one piece at a time. So in this piece, what do I have left? 5x times 1, which is 5x. Then there's my equal sign. Don't lose your equal sign. So on this one, I'm going to cancel the 1s. Very good. I actually have to multiply, not just smoosh. So 7x minus 14. Then there's a plus sign. The x minus 2's will cancel, and I have 10 times 1, which is 10. Where'd my fractions go? They're gone. If they're not gone, you did it wrong. Okay? They should be gone. Do we see, though, why we need every piece accounted for? Because what happens if you missed a piece? It's not going to cancel. Yeah, you're not going to have all the denominators cancel, and we want them all to cancel. Okay. So what's your next step say? It says solve. Well, all right. I got some like terms over here. Let's put those together. That's negative 4. Set this one equal to 0 or just solve like normal? Just solve. There's no x squared. I'm going to subtract 7x over. So negative 2x equals negative 4. Divided by negative 2, so x equals 2. What's your next step say? Check for extraneous, which again, you can write underneath there, look at restrictions. What were your restrictions? You can look at your LCD. What's your restriction? 2. So there is no solution. I know, you guys get so mad. You do all the work and you're like, no solution. All that for nothing. What's that? Correct. Yep. Now, guys, for me, I always write my LCD kind of off to the side. So then when I go to look for restrictions, all I have to really look at is my LCD because it's going to have every part and piece accounted for. How are we feeling after the first one? You like it? I like to hear that. Now, this method I'm teaching you right now will work for fraction equals fraction. But honestly, it's easier to cross multiply. But this method does work for that. Okay, so if you just really love this method, you could use it on all the solving ones. All right, so step one, factor your denominators. None of them factor. What is your LCD? It is 2x. I'm going to go ahead and write that over here. It is 2x. Step 3, multiply each piece by the LCD to cancel the denominators. So I'm going to multiply all of them by 2x. Again, don't be lazy. Please write them down. Also, do you see this little negative right here? Yeah. Just like before, we don't want to lose those. We can kind of pop those up like we always do. Are they held with the plus or minus? So you can cancel them, yeah. And isn't that what our goal is? To cancel our denominators? So 4 times 2 plus, cancel my 2's. So that's 5x. Cancel the x's. Negative 22. Doesn't that look so much nicer to solve? So much nicer. Yep, just subtract 8. So 5x equals negative 30. Divide by 5, so x equals negative 6. And then check for extraneous. What was your only restriction? 0 is the only restriction, so you're okay. Glad you like it. You're like, wait a minute, things got real. No, it's all right. It's not bad. Step 1, again, step by, oh, Bradley. Technically. Okay, nobody, stop listening, except for Briley. Briley, to answer your question, you could go through your adding and subtract. You could go through your adding and subtracting steps to get common denominators, to add them together, and then cross multiply. You could. Is it the easiest option? Heck no. There's always somebody every year who does that. You can, but I don't teach it because it's way harder. But yes, you could. All right, everybody else ready to listen again? Yes.
Because like when it says multiply each piece by the LCD to cancel it.
I can. All right, so can we factor the denominators?
No. You said there's an x plus 6.
It doesn't factor. Doesn't factor. Doesn't factor. What is my LCD? I agree with the x plus 6 and a 3x. Again, stop and think. Will you have every piece cancel? That's the question. So, guys, I need you to, if you're somebody who struggles with the LCD, if you think you know what the LCD is and you put it up there and you're canceling things out and you're like, wait a minute, that didn't cancel. It's a red flag. You didn't put the right LCD. Okay? So multiply by the LCD. So I'm going to write the LCD on all of these. And I know sometimes it's tedious to write them, but I want you to see what's happening. Okay, so cancel. So my 3x will cancel here. What do we have left? Good, 2x plus 12, bless you. Plus, what cancels here? The 3's. Now, there was a problem on the quiz that ended up with something like this, and you guys freaked out and didn't know what to do with that. Yes. I think you were the only one in this class, I think, who got that one right. We had a problem like that previously. We did. So what's 2 times x? So I'm distributing 2x throughout that. So what is 2x times x? And what's 2x times 6? Right? These two numbers are just being multiplied out here. 2 times x is 2x. So that's what you're distributing. Are we okay? So are we seeing where I'm getting the 2x that I'm distributing? Okay. And then over here, cancel out the x plus 6, and that's 24x. Good. Solve like normal or set equal to 0? Set equal to 0 because there's an x squared. So I definitely got some like terms. Let's put those together first. So 2x and 12x, 14x plus 12 equals 24x. All I did at this step was I put my like terms together. I just did one step there. All right, but we did establish we do need to set it equal to 0 because we have an x squared. So we'll subtract the 24x over here. So 2x squared minus 10x plus 12 equals 0. Now we set it equal to 0 so that we can factor. How does that factor? There is a GCF here. Yep, so let's take out the 2. And it's the lovely 6-5 combo. We got to be careful on our signs. They're both negative. Good. So it's going to have to be x minus 3 and x minus 2. Since they both have to be negative. Good. X equals 3 and 2. And then check for extraneous. My LCD was this. What were the restrictions? 0 and negative 6. So these answers, totally fine. Yep, those are good. How we doing? You all right? Okay. Set the denominator equal to 0. In this case, look at your LCD. Set it equal to 0 and solve. That's seriously all I'm doing. I'm solving the denominators. Doesn't matter if she can say it as long as she can do it. Okay. What do I do first? Can I factor any of those? Yeah, take an x. X minus 2. Perfect. My LCD, all my pieces are just going to be an x and an x minus 2. So I'm going to write it over here. It's very helpful, I think, to write whatever your LCD is, kind of like just off to the side. Just so you know what it is. It helps you with the restrictions, checking for extraneous. Okay, so x and an x minus 2. So I'm going to write that on all of them. You're right, it does. But again, don't be lazy. This is not the time to be lazy, and you know me, I'm queen of lazy. If you notice my papers, I still write them down on all of them, just like that. Yep, this will all cancel when I have 10. Cancel the x. Good. 4x minus 8, just distributing that, equals. Good. And that's just 5x. Look how much easier that gets. Take those fractions out of there. Good. We got some like terms. I'll just put those together. We get 2 plus 4x equals 5x. I just put my like terms together. Subtract my 4x. X equals 2. Why? What are my restrictions? 2 and 0. No solution again. Wasn't it a 2 last time when it was no solution? Not necessarily. How are we feeling? This should be the harder of them. Are we feeling okay, though, with it? Most students, if you struggle, it's usually here. All right, well, I'm glad we're feeling better. As far as that quiz. I still have a couple people finishing it up, and then the next 2 days are weird. So Friday, we will start the day by going over that quiz. Like, we will do our lovely data tracking. Your class, they're in the grade book. If you haven't seen them, you need to look. They're atrocious. Seriously. There was no A's, 1 B. The rest were C's, D's, and F's. They were terrible. I think there were 6 of you who left the back blank. Blank. 3 people all sat at one table who did that. 3 of the blank backs all sat at the same table group. They may need to move seats. Okay. You guys want to try this one on your own? Yeah? 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 Do it on your own. Follow your steps. We got this. Give it a try. So step 1. Some of you didn't do that. Factor denominators. You got a difference of squares sitting right here. This is x plus 1, x minus 1. Okay? You've got a factor. Guys, please read your steps. Do them. All right, LCD, every part and piece is going to be just x plus 1 and x minus 1. Now, guys, the whole point of this is that you can cancel your denominator with whatever you put up on top. If you don't have your denominator as a piece on the top, it's wrong. Okay? You have to have that piece. So multiply all of these. So all of these get an x plus 1 and an x minus 1. So the whole point is to cancel. Every one of your denominators should cancel with something you have on top. If you don't have all of those pieces up there, you did something wrong. Okay, so I have 2 and an x minus 1, so that becomes 2x minus 2. Got to distribute through the whole thing. Then there's a plus sign. And then I will cancel the x minus 1 and distribute here. X squared plus x. There's my equal sign. Don't lose track of that. And then both of these cancel, and I just have a 2. So at step 3, your fractions should be gone. If they're not, you messed up. All right, I have like terms sitting over here. So I have 2x plus x is what? 3x minus 2 equals 2. I have to set equal to 0 because I have an x squared. So when I subtract 2, that does not cancel out. Some of you like to think it does, so that's minus 4. Okay, it does not cancel. And then that will factor. X plus 4, x minus 1. So then x equals negative 4 and 1. If you look back at your restrictions, they would have been plus or minus 1. So that one's no good. So it's just x equals negative 4. Again, if you like this method better than what we did yesterday, this method works on all solving. Okay? I think cross multiplying is easier if it's just fraction equals fraction, but for whatever reason, some people, you may like this better. That's fine. All right, last one. What does the step say? Sam? All right, guys, I want to kind of draw attention to the question that Izzy just asked, because I know someone's going to do it as well. Her question was, do I have to factor the GCF out of the top? It never tells you to factor the numerator, so no. Yes. Sure. All right, so let's go through our steps. And I know right where we're getting tripped up. We'll go through it. So step 1, give your denominators factor. No. This one's over 1, so we don't lose that. What is my LCD? Good. So again, I'm just literally walking across my problem on the bottom. I'm just writing everything down. So x plus 4, If you want, I can put the 1 there, and then I need an x minus 1. I'm literally right across the bottom. Write them all down. Okay? So that goes on the tops of all of them. So x plus 4 and x minus 1. If you want the 1, you can write the 1. It's not really necessary because if you multiply by 1, it doesn't change anything. All right, so we do that so that they cancel my denominators, right? So I'm going to cancel the x plus 4s. If I multiply 6x times 1, I get 6x, and then that's what gets distributed here. So 6x squared minus 6x. And I have a plus sign, and this is where people get lost. All right, so you are multiplying. You're multiplying a 4 times an x plus 4 and an x minus 1, right? You're multiplying all of that. In the past, when we've talked about this, you start with the back, right? You'd multiply these two together, get that answer, and then bring down the 4, and then multiply the 4 through. That's what you should do. You could multiply the 4 through the first one, but what people want to do is they want to multiply the 4 by everything. Think about it this way. If I asked you to multiply 2 times 3 times 4, would you multiply 2 times 3 and then 2 times 4 and then those two together? You'd multiply 2 of them together and then multiply that answer by the other one. Same idea here. Okay? So that's what we want to do. So come back up here. I'm going to start with just these two, and at 4 it's going to have to just come down, right? And again, if you want to do this whole multiply as a side note and then write it up in here, that's fine too. That might be easier. Let's do that. We'll just do it as a little side note and we'll bring it right back up. Here, we'll move my little side note over there. Yeah, I got a little crazy there. Ah! Okay, we'll just leave it. Well, right there. We're good. All right, so let's do these two first. So we have x squared minus x plus 4x minus 4, which is x squared plus 3x minus 4. And then this one would drop down, and we multiply that one through. So 4x squared plus 12x minus 16. Yeah, it might just be easier to have it as a little side note, multiply, and then let's put it back. Don't do GCF. You're going to go right back to where you were. Don't factor it. You'll go right back to where you started if you factor. All right, so that's what goes up here as the next part. 4x squared plus 12x minus 16. Not to each. That's why I don't want you to do that, because that's wrong. Nope. Do it like that. That's the way we practice. It's the way we've trained all semester. Do it that way. Equals. Here, the x minus 1's cancel. So I have to distribute those. So that gives me 2x squared plus 8x 2x plus 8. Let me stop there before we get any further. Make sure we're okay. And the question earlier was, is it supposed to be this long? Yeah. Especially if you didn't do the little, that we did it as a side note, so it kind of was off to the side. Otherwise, I'd be even longer up there. Okay, so let's kind of clean this up a little bit. On this side, we have some like terms. 10x squared, negative 6x plus 12x, and minus 16. Over here, I got some like terms. 2x squared, okay. Do you have an x squared? Yes. So that means I have to set it equal to 0. So subtract 2 over here. Subtract the 10x. Subtract the 8. Minus 24. All right, hold on. Slow down. Slow down. Let's make sure everybody's on the same page. At this step, yes. So then from here, GCF, 4. So 2x squared minus x minus 6 equals 0. So we're going to try to factor that. Good song. Good song. Did you put it on silent instead of just turning the phone off? All right. Options for A. We have 1 and 2, so 1x, 2x. 1 and 6 or 2 and 3?
Yeah, I didn't know. Yeah, no. Two in the first one. Yeah. Oh wait, you just said. Yeah, I did X.
So that's 4 minus 3. My signs are backwards.
Yeah, I was about to say I did X minus.
That's not going to work. X minus 3 and x plus 2? How are you going to get a 2x squared in the beginning? All right, and then we're solving. So x equals, baby brother, give me an answer. No. So 2, negative 3/2. And then check for extraneous. What were your restrictions? Negative 4 and 1? I'm good. You had that right, didn't you? Awesome.
Why?
Now, is every problem going to be that hard?
Yes.
No. Honestly, that's probably about as hard as the ones I would give you. That would be like top of the line, hardest one I give you. You gotta focus. You're right. Do you guys know how to do all that multiplying? You do. But if you miss one step, one sign, whole thing's wrong. Yeah.